The open-close principle is one of the 5 solid principles. It states that a class should be open for extension but closed for modification. This means that we should be able to extend the functionality of a class without having to modify the existing code in that class. In other words, you should be able to introduce new functionality without compromising the existing functionality. When code is extended rather than modified, there is less risk of introducing bugs. Bertrand Meyer introduced this principle in his book Object-Oriented Software Construction. Meyer's original approach was to use inheritance as a core mechanism to achieve the open-close principle. If a behavior coded in a class needs to be changed, a way of doing that is to create a subclass and override the methods as necessary. No change to the superclass is necessary, just new code in the subclass. Let me show you an example. There is a class MasterCard Validator. It's a pretty simple class. There is one public method isValid which tells us if a MasterCard is valid or not. So Meyer's approach is to use inheritance. If we want to add a Visa card validator, we do it by extending this class and override the isValid method. In this example, we follow the open-close principle. The code is open for extension and closed for modification. We can add new card validators and we don't have to modify the existing validators to do it. But there is one problem. The inheritance introduces tight coupling between the classes. If the isLengthCorrect method is changed, it affects the Visa card validator. Also, there might be some methods which are only relevant for MasterCard validator, and because we use inheritance, the Visa validator will also extend these methods. That's why Robert Martin and others redefined the open-close principle to a polymorphic open-close principle. Their approach uses interfaces instead of superclasses to allow different implementations which you can easily replace without changing the code. Instead of inheritance, we introduce a layer of an abstraction with different implementations in our design, and we avoid tight coupling between particular classes. Let me show you an example. Now there is an interface credit card validator, and each implementation is responsible for their own validation logic. There is no coupling between them. The interfaces are perfect solution for open-close principle. They should be closed for modification, and you can provide new implementations without affecting the old ones. Keep in mind that we cannot design our code to be completely closed for modifications. Nevertheless, we should follow the open-close principle as far as possible.